Hey everyone, welcome back to the Tech Packs. Today, we're diving into a game-changing project, a drowsiness detection and vehicle safety system. This project integrates Raspberry Pi, Arduino UNO, and a variety of sensors to keep drivers safe on the road. Objective of the project. The main goal of this project is to prevent accidents caused by driver drowsiness, intoxication, and speeding by providing real-time voice alerts and controlling the vehicle accordingly. All right, the system has detected drowsiness. We all know how dangerous the roads can be when a driver is tired, distracted, or intoxicated. According to studies, drowsy driving and drunk driving contribute to thousands of accidents every year. This project aims to create a smart system that monitors these critical conditions and keeps the driver safe. Now, let's see it in action. So let's dive right into it. All right, let's power on the system. As soon as we turn it on, you'll notice the project name shows up on the LCD for about 2 to 3 seconds. Once that disappears, the LCD starts displaying the vehicle speed in real time on the top row, while the second row will show any alerts based on what the system detects. Right now, we're not moving, so no alerts yet. Next, I'll connect the USB cable to the Raspberry Pi. This sets up communication between the vehicle and the Pi, allowing it to receive alerts and send email notifications. Now, I'm going to run the Python script on the Raspberry Pi, which will handle drowsiness detection. So, let's go ahead and do that. Now for the fun part, starting the vehicle. I'll press the speed increase button to start moving the vehicle. At this point, the alcohol sensor kicks in, checking if any traces of alcohol are present. If it detects alcohol, it won't allow the vehicle to start, and you'll see an alert pop up on the LCD. Also, the Raspberry Pi will send an email alert to the provided email address. For this first test, I won't simulate alcohol detection, so the vehicle will start and reach a speed of around 40 kilometers per hour. You can see that right here on the LCD. Speed, 40 kilometers per hour. Now let's slow it down a bit with the decrease speed button. Okay, now I'm going to simulate a scenario where the driver is under the influence. Before pressing the start button again, I'll place this marker near the alcohol sensor to simulate a drunk driving situation.
Alcohol
And boom,
detected.
the system detects alcohol, refuses to start the vehicle, and as you can see on the screen, it says alcohol detected. Also, the Raspberry Pi sends an email alert. You really can't drive in this condition. Now let's test the obstacle detection. I'll increase the speed to 70 kilometers per hour. At this speed, if the ultrasonic sensor detects anything in front of the vehicle, it will show obstacle detected on the LCD. Let's see that in action. And there it is.
Obstacle detected. Pay attention.
The system alerts us right away, helping to avoid potential accidents. Finally, let's push it to the limit. I'm going to increase the speed to over 100 kilometers per hour. At this point, the system will trigger an overspeeding alert.
Overspeeding detected. Slow down.
You'll see it pop up on the LCD, and just like before, an email alert will be sent through the Raspberry Pi. And there it is, overspeeding alert on the LCD, and the email notification has been sent as well. So there you have it. Moving on to the next feature, drowsiness detection. The Raspberry Pi is monitoring the driver's face using a webcam. If it detects drowsiness, the system will immediately send an email alert and display a warning on the LCD. Let's simulate that now. Alright, the system has detected drowsiness, and you can see the alert being sent via email. Pretty cool, right? And once the driver returns to normal, everything goes back to monitoring mode. It's super responsive. Now, it's time to check if the email alerts for these events have been successfully received. Let's head over to my inbox and see if the system has sent the alerts as expected. Now, as you can see, we have some new messages in here. These are the alerts sent by our vehicle safety monitoring system. Here's the first email. It's an alert for drowsiness detection. Let me open that. As you can see, the subject of the email clearly says, drowsiness detected. The email says, driver is feeling sleepy. That means our deep learning-based detection system worked flawlessly and triggered the alert. Now let's check out the next one. This is an overspeeding alert. I'm opening it up, and it shows overspeeding alert as the subject. The message says, vehicle speed limit is crossed. It's running over 100 kilometers per hour. Just like the drowsiness alert, this email was sent automatically as soon as the vehicle crossed the speed threshold. Finally, let's take a look at the alcohol detection alert. Here it is. The subject says, "Alcohol detected." Let me open it, and the message reads, "Driver is drunk. He/she probably consumed alcohol." This confirms that the system not only displayed the message on the LCD screen, but also sent the email notification successfully. So there you have it. Our system sent out 3 critical email alerts, one for drowsiness, one for overspeeding, and one for alcohol detection. Now, let's take a look at the key components in this project. Raspberry Pi. This handles deep learning algorithms for drowsiness detection and sends live alert via email. Arduino UNO manages all the sensors and controls. RPM sensor and DC motor simulates the vehicle's speed. Ultrasonic sensor detects objects in front of the vehicle. Alcohol sensor monitors for any signs of alcohol in the driver's breath. LCD screen displays alerts in real time. Push buttons control the vehicle's speed. Power adapter, one 12-volt power adapter to power the Arduino and all the sensors. Second one, 5-volt power adapter to power the Raspberry Pi. Here's the full circuit design. Let's break down the hardware responsibilities and connections. First, the Raspberry Pi is the brain behind drowsiness detection. It's connected to a camera module that captures real-time video of the user's face. The camera is constantly monitoring for signs of fatigue, like eye closure, using a deep learning model to detect drowsiness. The Raspberry Pi uses its serial communication to send signals to the Arduino when drowsiness is detected, and also responsible for the email alerts. Now let's move to the Arduino UNO, which handles most of the sensor and alert operations. The Arduino is connected to several key components. First, we have the LCD display, which shows information such as the system status or alert messages. This is essential for giving the driver visual feedback when the system detects drowsiness. Next, the ultrasonic sensor is connected, and its role is to detect obstacles ahead of the vehicle, adding an extra layer of safety. If an object is too close, the system can warn the user. One of the key hardware elements is the speed sensor attached to the motor and wheel setup. The speed sensor continuously monitors the speed of the vehicle. The motor driver, L298N, is connected to the DC motor, which controls the vehicle's speed based on input from the speed control buttons. The user can manually adjust the speed using the speed increase and speed decrease buttons, which are wired directly to the Arduino. These buttons give the user control over the vehicle's pace. We have integrated an alcohol sensor with an Arduino, which is connected to the A0 pin. This sensor detects the amount of alcohol in the air or breath and outputs an analog value. This value can then be processed to determine whether a person is intoxicated or not. For alert mechanisms, the Raspberry Pi can trigger mail and audio alert based on the severity of the situation. Now let's move to code explanation part. We have 2 codes for this system, one for the Arduino UNO and the other for the Raspberry Pi. First, let's take a closer look at the Arduino code, which is responsible for controlling the system and sensing incidents like alcohol detection, overspeeding, and obstacles. We start with 2 key libraries, one for controlling the I2C LCD and another for serial communication between the Arduino and Raspberry Pi. The LCD displays important messages like speed and alerts. Next, we declare pins for our sensors. The speed sensor connects to pin 2 and counts pulses to calculate speed. The ultrasonic sensor detects obstacles, and the alcohol sensor checks for intoxication. We also have buttons for speed control, using PWM signals for motor control. In the setup function, we initialize the LCD and configure the Arduino to read from the sensors and buttons. The speed sensor triggers an interrupt with each pulse, allowing real-time speed measurement. Speed monitoring relies on counting pulses to track wheel revolutions. Using the wheel circumference, we calculate and display speed on the LCD. Speed control involves 2 buttons, one to increase and one to decrease speed. If the alcohol sensor detects high levels, the vehicle won't start, displaying an alert on the LCD. For obstacle detection, the ultrasonic sensor measures distance, alerting the driver if something is too close and potentially stopping the vehicle. The LCD continuously updates with alerts, like alcohol detected or overspeeding alert. The motor driver manages vehicle movement based on sensor inputs, preventing operation when alcohol is detected and triggering alerts for overspeeding, including email notifications from the Raspberry Pi. That's how our vehicle safety system works. We've covered speed monitoring, obstacle detection, and alerts, all aimed at enhancing vehicle safety. Now let's take a look on Raspberry Pi code and see how Raspberry Pi processed this data received from this Arduino code. First up, let's talk about the essential libraries that make this system tick. We're using CV2 for all things computer vision, dlib for precise face detection, PETX3 to give our system a voice with text-to-speech alerts, scip.spatial.distance to measure distances, threading for running tasks side by side, serial for communicating with our Arduino, and SMTplib along with SSL for secure email notifications. Exciting, right? Now let's get into initialization. We kick things off by setting up our text-to-speech engine to deliver audio alerts. We create a message queue and launch a separate thread for processing these alerts. This ensures we can keep monitoring while keeping you informed. Pretty cool, huh? We also establish a connection to our Arduino on Slav TTY-ACM0, allowing us to get real-time data from sensors. Talk about staying connected. Next, we configure our email credentials. We define a function called sendEmail to notify you when alcohol or drowsiness is detected. Safety first, right? Now, let's look at how we handle incoming data. The serial reader function runs in its own thread, checking for signals indicating alcohol consumption or overspeeding. If it detects either, it immediately sends out an alert. That's some proactive safety right there. Moving on to object detection and monitoring drowsiness, we leverage the MobileNet SSD model to detect people within the camera's view. As we capture video frames with OpenCV, we analyze facial landmarks to assess drowsiness by calculating the eye aspect ratio. If our system detects drowsiness when the eye ratio drops below a certain threshold, we trigger an alert. You'll receive an audio warning and an email notification, along with a visual alert until the driver's alertness is back. Talk about a wake-up call. Finally, we ensure a clean exit. When the program is terminated, all resources are released properly, including camera feeds and connections, to avoid any resource leaks. And that's a wrap on our vehicle safety monitoring system. All right, that wraps up the demonstration of our vehicle safety monitoring system. As you've seen, it integrates multiple safety features like speed monitoring, alcohol detection, obstacle detection, and real-time drowsiness alerts, all working together to ensure a safer driving experience. What's really impressive is how smoothly everything functions, from detecting alcohol and preventing the vehicle from starting to monitoring drowsiness using deep learning and sending email alerts in real time. The obstacle and overspeeding detection features add another layer of protection, making sure the driver stays within safe limits. This project showcases how technology can play a huge role in improving road safety. I hope you found this demo informative and exciting. Thanks for sticking around to the end. We've seen how this drowsiness detection and vehicle safety system can help prevent accidents and save lives. If you enjoyed this video, don't forget to like, share, and subscribe for more amazing tech projects. Check out the description for more details on our product. Visit our website to purchase the complete package. Browse, select items, and click on Buy Now. Fill the required fields, then securely proceed to checkout, and you're ready to begin your project journey. Explore our site now to get started. Thank you for watching our video.